So I've been wanting to do this video for a while, and the idea of this video is to just kind of answer the question, what's faster? If you search forums on Unity and coding tips, there's a lot of places that will say, don't use updates on individual objects. It slows things down, there's better ways to do it. And so while I believed that, and I've seen evidence, I wanted to do a little bit of measuring of that myself. So what I've done here is I've created 1,024 cubes that are rotating. Their scale is changing, and they are moving up and down. So we're going to do this three different ways. One way is that each cube is going to have its own update function on it that calls the three lines that do the scaling, the moving, and the rotation. So the second way will be that each cube subscribes to an event, and a manager, so to speak, each frame will call that event and activate the same lines of code. The third and final way will be that a manager will look out into the scene and find all the spinner objects, this C# script that's on all the cubes. It will add all those objects to an array, and then in an update function, the manager will loop through that array and call the public function that causes the motion of each cube. And so what I want to look at is, what is the effect on frame rate? How does this really affect the performance of your game? Now, granted, 1,024 cubes is something unrealistic for a lot of games. You're not going to have that many objects. And I suspect for a lot of indie games, doing it either way or any of the ways doesn't really matter all that much. But sometimes you want to scrape out every little bit of performance that you can. Let's take a quick tour of the scene so we can see what is built in here. So here you can see I've got my cubes all built out in a nice array, and then just parented to an empty object here so that they are kind of nice and tidy in hierarchy. And you can see each cube is just the default Unity cube with this cube spin script attached to it, and we'll look at that in a bit. Here on this stopwatch object, I have my stopwatch script. I will share this full project. You can download this and look at the script and critique and criticize as you want. But what this is going to do is give us a rough measurement of frames per second. The way this is going to work is I set out a max number of frames. This is how many frames we're going to run it for. It's going to keep track of a few things, and it's also going to do multiple runs. What I found is often the first run is slow as Unity is initializing things, your scripts are initializing. Whatever's going on, the first run tends to be a little slow. So we're actually going to do 10 runs, and when it gets to 10 runs, it stops executing the code. We got our results here, kind of an average FPS for the run. The current FPS, this is per frame. This goes all over the place. You can kind of see down here in my profiler, right? There's all these spikes. And so this number jumps all over the place and isn't all that important. And here, this list here will track the average FPS for each run. And then we'll average them as we go. Here on the canvas, turn this off just for the intro here. I'm going to turn this back on. All I have is a panel with a text object on it. I believe the text has the script on it. So this has got a stat script on it. And what this is going to do is just basically go look at that stopwatch script and print things out to the screen to make it reasonably nice to look at. So we don't have to look at just the inspector. We get a little bit nicer text to look at. So first, let's start the testing with no script getting called. So here we have just the scene with the cubes, and it's running with no updates going on. There's nothing spinning the cubes. And I'm just doing this for a baseline test. So no surprise here, we're sitting in the 140, 150 FPS range. And once again, I lost about 40 or 50 FPS on all the tests across the board simply by having the video capture running. After 10 runs of this, what we see is we have an average FPS of 143, almost 144 FPS. So if we go to our code, what we can do here is go to the cube spin, and we're going to turn on the update function so that each cube is running its own update function. Go back into Unity, let it recompile, and we're going to run that test again. And now our cubes should animate, and you can see just already off the bat, our FPS is much lower. So we let this run through 10 runs of 1,000 frames each. What we're going to find is that we have an average with the update of about 76 frames per second. So we almost cut our frame rate in half. Not a big surprise. We weren't doing anything before, and now we're doing a decent amount, and our FPS has been cut quite a bit. And we're going to go back into our code now, and we're going to comment out the update function so that is no longer running. We're going to go into our spinner code, and you can see here that the update is already commented in, so to speak, that script was not running in our last scene. So what this is going to do is, again, grab that array of objects and loop through it each frame. So if we enable that script and push play, we'll still have animated cubes, but we'll be doing this in a different method. And let's check out and see what the difference in the FPS is. So again, letting this run for 10 runs of 1,000 frames each, what we find is that the results are we get something closer to 82 frames per second. So we've gained back about 6 frames per second by removing the update function from each of the cubes and having a single update function on a manager type object. Now that's not a lot necessarily, but this is one script, this is one action, and I know it's over 1,024 cubes, but in a game this can save you some precious, crucial FPS. And it was done pretty simply, pretty easily, without having to really restructure the code all that much. Okay, so now with that done, we're going to go back into Visual Studio to comment or change our code. We're going to comment out that for each loop that was cycling through the array. We're going to comment out the start function because we don't need to get that array. And we're going to comment back in that part of the code that's going to call the event. And then we're going to go into the cube spin script and comment back in the enable and on disable that will allow the subscribing and unsubscribing to the event. If we push play, once again, we'll have animated cubes and we'll let this run and see what our results are. At the end of 10 runs of 1,000 frames each, the end result, the average FPS, was just right on 80 FPS, which was a little bit of a surprise to me. I was a little surprised to see that this event calling was slower than the looping through the array. This is my preferred way to do it. I do prefer to use events over arrays, but maybe this will change the way I do things a little bit. To summarize that, what we've got is, again, our baseline with no animation in the cubes was 143, 144 frames per second. When we ran the update on each individual cube, we had a frame rate of about 76 frames per second. With the manager looping through the array and just the one update function on the manager, we had a frame rate of about 82 frames per second. And then again, with the manager calling the event each frame, we were sitting around 80 frames per second. So we can clearly see kind of the common knowledge, if you will, that having an update on lots of different functions is not the most efficient way to run your code. That said, our gains are fairly small and may or may not matter depending on the genre that you are designing for. I also went through and reran all these tests without the screen capture, so you can get values that are a little bit more like what you would see in a game. And as a result, the difference there was a lot more dramatic. So again, with the no action, with no animation going on, I was sitting at around 179 frames per second. With the update calling, again, and the update on each of the individual cubes, I was sitting at about 109 frames per second. And then with the manager looping through the array, I was sitting at about 125, 126 frames per second. And what was interesting, I ran this a couple different times, without the screen recording, the events, or the manager calling the event, as opposed to looping through the array, was actually faster. And I was sitting at about 127, almost 128 frames per second. It was a pretty interesting result there, that with the video or screen capture off, the fastest method was different. So again, the difference between 125, 126, and 127, 128 is pretty minimal, and could just be some background issue. But again, like I said, I tried it multiple times, so I'm not sure exactly what's going on there. Nonetheless, the main result here is that having an update on each individual object is not the best way to run your code and your script. And in fact, I gained almost 20 FPS by having a manager calling the function rather than each individual object having an update that calls the function. So I thought that was pretty interesting. Hope you think that's interesting as well. If you have any questions, comments, leave them below. If you liked the video, give me a thumbs up. If there is something else that you'd like to have compared, what's faster? If X is faster than Y, let me know. I'm happy to do some more videos on this as well. Thanks for joining. I hope it was interesting and useful, and I'll see you next time.